All right, everyone, welcome back. This is 7.4 Exponential Equations. Now we're going to focus on two learning goals: to solve exponential equations and to solve exponential equations with logarithms. Now, diving right into it, we have three properties that are really going to help us work with these types of equations, okay? And, some of them might feel kind of explanatory, all right? The first one is that if we have b to the power of x is equal to b to the power of y, then very clearly x must equal y. Now what I mean about this is that if I have, 3 to the power of, x plus 2 is equal to 3 to the power of, we'll say x, just say y. Let's go with y, okay? That these expressions, x plus 2 and y, have to be equal to each other, right? Because if we're going to say that 3 to the power of x plus 2 is equal to 3 to the power of y, then these have to be equal, and that's really our new equation, okay? Now the next one is when you have a log over here, a log base of x is equal to a log base of y, then the same exact thing happens. We can set, again, x is equal to y, okay? And then finally, and this, this one we kind of know a little bit, right? It's when we have log base x is equal to a, then very clearly we know that b to the power of a is equal to x, okay? Which that one we know pretty well. We're going to leverage these three to solve equations, okay? So let's just dive right into it. Here's our first two. I'm going to do them, and then I'm going to have some for you guys to do, okay? So here, right off the bat, 2 to the power of x minus 1 is equal to 16. Well, let's jump back to our properties real quick, okay? Well, first off, there's no logs, so we don't have to look at these two. But we have b to the power of x is equal to b to the power of y. Same base, we set the exponents equal. But these have different bases, right? So a little trick that you can do is we can look at 16 and go, can we write 16 to have a base of 2? And well, you can, right? Because 2 to the power of 4 is 16. So we can rewrite this. 2 to the power of x minus 1 is equal to 2 to the power of 4. Now we have the same base, so our real equation is x minus 1 is equal to 4. We add 1, and we get x is equal to 5. And that makes sense if we plug it back in, right? 5 minus 1 is 4. 2 to the power of 4 is 16. Everything works, okay? Now, it isn't always that easy, right? Over here, we have 4 to the power of 8, and we have 64 to the power of x plus 2, okay? And, we don't have the same base yet, but we could take 64 and write it as a base 4. That would be 4 to the power of 3. But there's already an exponent there. So our new exponent is going to have to multiply with that. And this is what I mean. So we take 4 to the power of 8 is equal to 4 to the power of 3 times x plus 2. When we do this, the exponent that we just made is going to multiply with x plus 2. So we get 4 to the power of 8 is equal to 4 to the power of 3x plus 6. Now we have the same base, so we easily just, we just set those equal to each other. Okay, so 8 is equal to 3x plus 6. You solve, minus 6, you get 2 is equal to 3x. Divide by the 3, and you get x is equal to 2/3. Okay? All right. Let's give, 2 for you guys to do, okay? This one should be kind of like the ones we just did. This one's a little bit different with the fraction, but I think you guys can handle it, okay? So I want you guys pause it, give it a try, and then I'll go over it. Okay, so hopefully you got these, right? You see we have a base 9, we have a base 27. 27 can be written as a 9, 27 can't be written as a base 9, right? But it can be written base 3, and 9 can be written base 3 also, all right? So here, this will be 3 to the power of 2 times 2x. And then over here, this will be 3 to the power of 3 times x plus 1. change up the color here a little bit. So then we get 3 to the power of 4x because we multiply those. And then we get 3 to the power of 3x plus 3. Okay. Now, we have the same base, so we can set our exponents equal to each other. So we have 4x is equal to 3x plus 3. And we need to solve for x. So we minus the 3x, we minus the 3x. We get x is equal to 3. Okay? And that's your answer. Now for this one on the right, it might have seemed a little bit more difficult because we have, a 25 here, which doesn't seem to have any exponent, right? Although there is a 1 there. And then we have 1 over 25, right? Looking at these very quickly, when I see this 1 over 25, 25 to me very clear, speaks, base 5, okay? And then once I realize that 25 speaks base 5, I kind of look over here, and 125 also speaks base 5 as well. So 5 to the power of 3 gives us 125. And then 5 to the power of negative 2 gives us that, and we multiply it here. And we get 5 to the power of 3 is equal to 5 to the power of negative 2x minus 6. Okay. Now we can set the top equal, so that's 3 is equal to negative 2x minus 6. We solve for x. 9 is equal to negative 2x. We divide by the negative 2. And we get x is equal to 9 over 2, or negative 9 over 2. Okay, and that's your answer. A little bit more difficult, right? But nothing you guys can't handle. Now let's go to the next one. All right, so now we're bringing in the logarithms again, okay? And the feedback I kind of got in the last video was like having trouble, lining up the properties. So as you saw, I lined up the properties for the previous problem, so I'm going to do the same. So we see a lot of logs here, right? We see, log 20, log 20, log 2, and log 2, so those are the same base. Let's go back here and look, okay? This one right here is really going to help us out with that. When we have two logs with the same base that are equal to each other, we really just take what we're taking the log of and set those equal to each other. So when we go to this problem, well, log 20 of 8 minus 2x and log 20 of negative 3x minus 10, we can really just write this as 8 minus 2x is equal to negative 3x plus 10. And now we can just solve this for x, right? So I'm going to add the 2x. He could have gone the other way. This cancels. You get 8 is equal to negative x plus 10. You minus the 10. Yeah, I probably should have gone the other way. That's okay though. We get negative 2 is equal to negative x. We divide by the negative 1. And we get x is equal to 2. Okay. Now let's verify that, right? 8 minus 2 times 2, that would be 8 minus 4. Okay. And we get 4. And then here, negative 3 times 2 is negative 6. Negative 6 plus 10 is 4. So we got the same number. This works. Okay. And now we can do it with this one as well, right? We have log base 2 and log base 2, where they're equal to each other. So we can take what we're taking the log of and set those equal to each other. So we get m squared plus 5m is equal to, sorry, I don't want to make that look like a minus, 5m plus 9. Now we solve for m, but we kind of notice off the bat that, there's a square in this one, right? And that's okay. So let's minus this 5m. Minus this 5m, we get m squared is equal to 9 because it's going to cancel out both of those. And hey, look at that. That square is going to get rid of itself. Now maybe you might have to do some quadratic formula here. That is a possibility. So you need to be prepared for that. But in this one, we got lucky, solved by square root. We get m is equal to plus or minus 3. Okay. So, not too crazy yet, right? That'll be the next lesson. Oh, okay. So, here's two for, well, these are the other property, right? Maybe I'll have you do this one. Nah, I think you guys can do this one, all right? This is a different property, yes, but, you should be able to leverage this third property here by really just converting it to exponential form. So how about I do one and then I'll give you guys one. So I'll do the left one, right? By using that basic definition of what a log is and rewriting an exponential form or using the circle method, whatever you want to call, we get this 3 to the power of 2 is equal to x plus 1. Well, 3 to the power of 2 is just 9, right? Is equal to x plus 1. You minus the 1. You get 8 is equal to x, or x is equal to 8. So we really just used what a logarithm is there, okay? Now, there's this one over here, all right? Very, very similar. I want you guys to try this, but I will give you the one tip. Before you do this circle method, get this log here by itself, okay? So pause it, give it a try, see if you can figure this one out. All right, hopefully you got it. Okay, hopefully you subtracted that 7. You're going to get log 2 of 5n minus 4 is equal to 4. So that cancels, right? And then we're going to use really just what it is. 2 to the power 4 is equal to 5n minus 4. Using that circle method, right? 2 to the power 4 is equal to this. And then, oh, that's a bad color. Sorry, I'm like changing up so many colors. Okay. Then we're just going to solve for n. So this becomes not 8. It becomes 2 to the power 4 is 16. Add the 4. Add the 4. You get 20 is equal to 5n. You divide the 5. And you get n is equal to 4. Not too bad, right? Now there's this last one here. And believe it or not, this will be it. Maybe I'll make it under 20. Now this last one here has a little bit more to it. We might have to bring in some of those other properties. And that's okay, all right? So let's look back over here, right? We got, the natural log. This is both log base 10. This is both log base 10, okay? And that is equal to 2. So, we can't really use any of the properties in its current form. So we're going to have to maybe try and bring these together, right? We know the product rule. They're adding. They have the same base. So let's bring them together. This becomes log of 2x times x minus 5, right? Equal to 2. Now we can simplify that. So let's simplify it. Or let's just go right ahead and do our next step, right? So we technically have a 10 here. So 10 to the power of 2 is equal to 2x times x minus 5, okay? And now again, you could have simplified that already and then that would have just been there because that's going to be my next step anyways right now is to simplify it, right? And we're going to go ahead and solve for x. So we're going to distribute. We also get 100 here is equal to 2x squared minus 10x. Okay, so it is looking like we're going to have to do a quadratic formula on this one, right? So let's get everything to one side. We're going to get 0 is equal to 2x squared minus 10x minus 100. And because I don't like using an a value and I can see that I can take out a greatest common factor here, I'm just going to go ahead and divide out that 2. And I'm going to get 0 is equal to 2 times x squared minus 5x minus 50. Okay. Now, we set up our x factor. We get negative 50 on the top. We get negative 5 on the bottom. We ask ourselves what times what gives us negative 50. That adds to be 10. And that's going to be negative 10 and 5. Negative 10 times 5 is negative 50. Negative 10 plus 5 is negative 5. So I can rewrite this. That's going to be 0 is equal to 2 times x minus 10 times x plus 5. You solve for x, and you get x is equal to 10, and you get x is equal to negative 5. And that's it. Okay? Now, that was a lot of stuff. That was definitely a lot of stuff. Okay? But, I think you guys can handle this. There actually is no math talk for this one. So that's it. Hopefully I made it under 20, and I will see you guys next time.